Good morning, Dr. Rajesh Babu, sir.
And yeah, good morning to you all. Am I audible now?
Yes, sir. Yes, sir.
Okay. A glad good morning to you all. I'm proud to introduce today's speaker, Dr. K.Premkumar, who is an associate professor at Rajalakshmi College of Engineering, Chennai. He did his undergraduation in Syedabad Engineering College and post-graduation in SSN Engineering College. He completed his research under the guidance of Dr. B.V. Manikandan. Now, currently, he is working as an associate professor at Rajalakshmi College of Engineering. To his credit, he has published a number of conferences and journals, reputed journals. He is a recognized supervisor of an university. Currently, he is pursuing 8 scholars, I hope. Now, the guest speaker will present his presentation. Thank you.
Thank you, Rajesh Babu. Good morning to all. Today we are going to see about application of artificial intelligence to solar PV system. Okay, so my screen is visible to you.
Yes, sir.
Yeah. That means today's topic is application of artificial intelligence to solar PV system. So already last 4 or 5 days you have some view about artificial intelligence, right? So normally that artificial intelligence nothing but you have to simulate the human intelligence, right? That means we are going to mimic the thinking of human knowledge and then human intelligence in simulation point of view, right? That is called artificial intelligence. Same can be applied to real time also. Okay, so here we are going to see how we can apply that in artificial intelligence technique to solar PV system. So here I am going to demonstrate the maximum power point tracking algorithm for solar PV system by using artificial intelligence techniques. And then I'm going to consider only two kind of artificial intelligence. One is artificial neural network, and next one is adaptive neurophysics inference system. So I'm going to take these two topic, and then I'm going to explain with this two topic with Matlab simulation. So this is a presentation of this topic. So we have to discuss about ANN structure, and then next we have to discuss about ANFIS structure, and then we go for some simple example in ANN and ANFIS using MATLAB, and then we have to discuss about maximum power point algorithm for solar PV system and how we can implement that MPPT algorithm by means of ANN and by means of ANFIS for the solar PV system using MATLAB. So these are the presentation content for this topic. So first we have to discuss about ANN structure, artificial neural network structure. Okay, so it mimic the behavior of human brain, right? So human brain have different kind of neurons. So how that neuron going to be work in the human brain? The same concept going to be implemented in the artificial neural network. So this is a simple structure of that artificial neural network. So it have three layer, right? Layer 1 is known as input layer, and next layer nothing but hidden layer, and third layer known as output layer. Okay, so these layers are connected with the links, right? In between input and the hidden layer there are several links, so each link have some weights. So for example, you consider this link, so it has some weight, and same way that all link have some weight, okay, and also you can see the neuron. So now you can consider hidden layer. The hidden layer have different kind of neurons. So this is known as neurons, right? So the neuron also receive another input. So one input, nothing but that link from that input layer, and also they have some weights, and also it receive another input, nothing but the bias, okay. So each neuron have some bias, okay, according with the neural network structure. And also they have that neuron, each neuron have some activation function, right? So based upon the activation function, it allow the output from that neuron, okay. And then this hidden neuron, which are hidden layer neurons, going to be connected with the output layer neuron, like by using that links, okay. These links also have some weights, okay. This is known as hidden layer to output layer weights. So this is input layer to hidden layer weights, okay. So this hidden layer neuron is connected to the output neuron by means of links, and also that have different weights, okay. So this is basic structure. So how we are going to implement that brain behavior in that neural network, right? So you have to collect the data first. So how we are going to make that artificial neural network for the particular application or particular job, right? So for that you need to collect the data, the data known as input data, and then your target data, okay, target data. So you have to collect first the data. So after collecting the data, input and the target data, so we need to train that neural network, that artificial neural network, by means of this input and the target data. So what will be happen during training process, okay. So we have that input data for a particular application, and we have some target data for the particular application, okay. We got these two things, but we need to adopt this input target with that neural network. So what happened during training process? So during training process, what happened, that weights of the this input to hidden layer links and the weights of the hidden layer to output layer link going to be updated, and also the bias also going to be updated during training process. So for each iteration, right, each iteration it will supply the input and target value. So based upon input target value, the training algorithm, right, training algorithm will be update the weights, okay. After that, right, the neural net will be trained with some input and the target value, some value, right. So you have to take the actual output from that the corresponding input. So this is output from that AN. For example, we consider that is AN output, AN output. So this AN output and the target going to be compared, okay. So when you have to compare this AN output, after each iteration you will get some error, right. So that error going to be minimized. So error means here you have to take root mean square error or mean square error, right. RMS SE, and or else you have to take only mean square error, right. So our objective is, for training of artificial neural network, we have to minimize that root mean square error or mean square error with a change in iteration, right. So it can be minimized by means of that algorithm. So normally in feed forward neural network, we have to use back propagation algorithm or some other least square algorithm, right. So different algorithm have to used in order to update the weights, okay. So after some iteration, right, you will get some trained in neural network, right, for your input and target, right. So your trained network, that a trained network can be used for your application, okay. So this is a process of artificial neural network. So so this is a way of we are training the neural network, right. So So next you have to see about structure of ANFIS. The structure of ANFIS, right? You can see that the structure of ANN and the structure of ANFIS both are having similar components, right? So here also have input hidden layer and output layer. So here also ANFIS structure also have input layer. So input layer, and then in between there are several layers, right? So this is known as we can call this when compared with the ANN, it is known as hidden layers, right? And then it also have output layer, but the number of hidden layer is vary when compared to simple ANN, right? So it has different layers in between the input and the output. So that layer nothing but composite function layer, falsification layer, and the normalization layer and depreciation layer. Okay, and also in between each layer, right? For example, consider composite layer to falsification layer. There are weight in between these two layers, right? And also in between that falsification layer to normalization layer, there are weights. So different weights is linking with the next layers, right? Okay, so there are link in between every two layers, right? Okay, why it is called ANFIS? Nothing but ANFIS, nothing but adaptive neurofuzzy inference system. Okay, so we are going to combine the characteristics of neural network, artificial neural network, and fuzzy logic system. Okay, so you have to take the best characteristics of neural network and fuzzy inference system and club it together. You have to frame the network, right? That network is look like a neural network, but the operation is mimic the fuzzy logic system. So network is like neural network, but operation, right? So the operation inside that ANFIS is similar to the fuzzy logic system. That means in fuzzy logic system, the structure having input membership function, and then we have rule base, and then we have despecification, right? So in between you have fuzzy inference system here. So this is FAS. So this is input membership function. So this is rule base. So this is despecification. Okay. So here falsification will be take place here. Okay. So this is our linking with the fuzzy inference system. So if we receive some inputs, it will deliver some output according with the fuzzy inference system rule base created inside the fuzzy logic system. Okay. So same way here also they have, this is known as falsification layer. This part known as this two layer known as a falsification part, and then this part known as a despecification part, right? And then this falsification despecification, that means this layer is going to be connected with some fuzzy rules. Here we are going to implement that neural network algorithm, right? Neural network optimization, that means weight updating algorithm here in order to update the weights of the two layers. So one is membership function layer, right? So this is known as membership function layer, and also this is despecification layer. This parameter in the membership function layer and despecification layer going to be optimized by means of neural network algorithm. Okay, so membership function layer, for example, I'm going to consider a Gaussian membership function for inputs, right? If you are going to consider Gaussian membership function for that input, then you will get two parameters. So one is the center of that Gaussian membership function, another one is you will get the sigma standard deviation of that Gaussian membership function. Okay, and also if suppose you are going to consider a triangular membership function, and then you will get three parameter. So right side point and the left side point. So left side point and right side point and the center point. So this point can be optimized according with the input and the target data, right? So this parameter, for example, when consider cosine Mabuse function or a triangular Mabuse function, so this parameter going to be optimized by means of neural network algorithm. Okay, for example, I'm going to consider this is point A, so this is point B, and this is point C, right? So this point A, B, C is the tunable parameter. Here C and sigma is a tunable parameter in the Mabuse function layer. So this parameter going to be tuned according with the neural network algorithm based upon that input and data. So here also infrastructure need input data as well as target data. Okay, so you need to generate input and target data according with your application. Okay, so based upon that input and target data, so you have to tune tune the parameter of this Mabuse function layer. Okay, and then you consider diversification layer, right? So diversification layer, we have the equation nothing but f and f1 to fn, right? So this function will be related that with the input, right, by using following formula. For example, p x plus qy. For example, we consider two inputs, right? Qy plus r, right? So x and y nothing but the inputs of the ANFIS network. Okay, so this is the output in the diversification layer for the each neuron, right? So in here you can see that here also there are tunable parameter nothing but p, q and r. Okay, so this parameter going to be optimized in the diversification layer by means of a neural network algorithm, right? So this parameter, the parameter in the tunable parameter in the Mabuse function and tunable parameter in the equation, this equation diversification layer output equation, right? So these parameter going to be optimized based upon input and target we are getting, right? And then after getting this input target, we have to use neural network algorithm concept to tune this parameter, right? So after that, what will be happen after training process? Finally, we will get a fuzzy inference system. Okay, so this fuzzy inference system FIS, right? So FIS going to be used for that means implementing that your corresponding application, right? So output of this science, right, is fuzzy inference system, that means fuzzy logic file, right? So that can be used for your application. Okay, so this is a function of the ANFIS structure. So next next I'm going to have some simple example, right? So I'm going to use simple example for ANN. So how to use that ANN and ANFIS tool in the Matlab. So for that I'm going to consider one example. So I'm going to generate sinusoidal waveform, right, by using ANN and ANFIS. So for example, I'm going to take sinusoidal, right? This is sinusoidal waveform. I'm going to consider the sinusoidal waveform is vary with theta. Okay, and then it have some amplitude, peak amplitude, and it also have some frequency. Frequency can be fixed during that simulation time, during simulation of that final model, right? So that theta, that for example, you consider sinusoidal waveform. So that when theta is vary in between 0 to 360 degree, so it will be very like sinusoidal. So you have to make some equation for that, right? So for example, I'm going to take our target is sinusoidal, right? So I'm going to take target which is equal to sine into sine of theta, right? Sine of theta, and then you can place some amplitude here. So what kind of amplitude you want, then you can place here. You can multiply it in the sine theta, right? So you want to generate the data for this sinusoidal waveform. Okay, so here input for that sinusoidal waveform here is theta, right? So you are going to vary the data and then you have to get the target value, right? So the theta going to act as an input for that sinusoidal system. The output of this equation will be t. This is the final your target, right? So you are going to generate the target value with for different theta value in between 0 to 360 degree. So first we need to collect the data. So we need to collect the data value, and then after collecting data, you have to generate the target by using this formula. Okay. After collecting this input data theta and the target, so you have to use that this data for training of AIN and ANFIS, and finally you can that final after training process you can use the AIN and ANFIS for generating the sinusoidal waveform, right? So how we can generate that sinusoidal waveform by using AIN and ANFIS training process. So let's start with that Matlab implementation. So just you have to create some new M file, right? Here I'm going to type CLC. CLC nothing but used for clear the screen. That means here you can type CLC, right? What happened? The data in the command window going to be clear, and then I'm going to use clear all. So clear all means it will clear the all data in the workspace. So when I'm going to execute this in command window, so you will see that so here the data in the workspace is going to be clear. Okay, so I'm going to use clear all, and then I'm going to generate the data theta, right? So here I'm going to type theta equal to the data going to be start from 0, right? 0, and then end with the 360. Okay, so we need to get the data different sample, right? Sample of 360 degree. So I'm going to consider a 100 sample, right? So further I'm going to divide 360 divided by 100. So every 3.6 degree, right, you will get the data. So I'm going to evaluate this function, you will get the idea, right? So after evaluating, you will see the data value here. So the data will be increase every, that means increase with the value of 3.6 degree, right? So totally we have 101 samples. So you can plot this theta also. So it is linearly varying, right? So every sample, the 3.6 is added with the previous theta value, right? So next I'm going to generate the target data, right? So I'm going to consider target equal to, I'm going to consider amplitude of that sinusoidal waveform equal to 5, right? 5 star sine of theta, right? Theta. So it will generate the data for the target. Okay, so I'm going to execute this file. It will ask for saving, right? Just you have to save some data one. Okay, after executing you will see that the data for target, right? So this is a target data. So I'm going to plot this one. Now you can see that what happened. You are not getting actual sinusoidal, right? If suppose you are going to increase this theta, or else because this sign, right, the sign is if you are using this one, right, then you need to provide the theta value in terms of radians, right? If suppose you are using theta, right, and then you can use sine d. You can type here, you will get some idea sine d, right? Sine of arguments in degrees, right? Because when you have to use only sine, what will happen? That the theta should be in radians, right? If suppose you are going to generate that detail in the degree, then you have to use this sign D. So now we got to execute this file. So now we can see the target. So you will get proper sinusoidal waveform. Now you see that you will get a proper sinusoid, right? So when you have to use some commands in the Matlab, so kindly conscience with that that mean clear details about that each commands, right? So then only you will get the proper output, right? So now we generated two details. One is input detail, right? And theta. Another one is target, right? So both are generated. So this is going to be considered for input and the target for ANN and the ANFIX, right? So next we go for a ANN training process, okay, in the MATLAB. So for that, just we go to type NN start, NN start here, right? In command, just you type NN start. So after that, you will get this kind of window. That is nothing but neural network training window. So here we are going to use only one thing, right? First option only. So you have to use curve fitting concept, right? So you have to fit the output target with the input data, right? So for that you have to use the fitting app. After that, just you will see the neural network fitting curve fitting tool, right? Next you got to click next button, and then here you need to choose the data, right? So here to choose the input data. Here you need to choose the target data for that training process. So here I'm going to select that input data theta, and then I'm going to select the target here. Okay, so after selecting input and the target data, right, just you to click next. See here you can see that you are going to fix the training samples for the training verification testing, right? So in total sample 101 sample, so training have 70%, and then verification is 15 and testing is 15%, right? So you can vary the samples also, right, here. So you can adjust the this number of samples used for training, validation and testing, right? So suppose I'm going to take 20%, what will happen to the training sample? The training sample percentage going to be decrease, right? So you can choose accordingly. Okay, so you will take the default value 70%, 15% and 15%, and then click next button. So next they ask number of hidden neurons in between input and output, right? So here you can see that this is input and the output layer. So in between we have hidden layer, right? So how many neuron we are going to allocate for the hidden layer? So in default they use 10 hidden layer. So if you want to increase the hidden layer, you can increase the hidden layer. But if you go for a higher number of hidden layer, the training process is more complex, because that during training process you need to update the weight, right? So it need to update the weights, this weight and this bias, right, according with your input and target data, right? So when you go for higher number of neuron, that computation time is very high, and also you may be not receive appropriate trained neural network, right? So you have to choose hidden neuron as default value, or else you got to choose plus 5% or plus 10% from the default value. Okay, so here I'm going to take only the default 10 neurons, right? Next I'm going to click next button. So here we are going to come for training of neural network, right? So here in default they have three kind of training process: LM method, BR method, SGC method, right? Okay, so you can choose any method. So for this fitting curve fitting application, so Just you have to take that LM method, okay, and then you have to start the training process here. So this button used for train the neural network for given input and target, right? So click, so you will get the training process right here. So total iteration is completed is 1000, right? And then here you will see that the mean square error after training process is about 1.5 into 10 power minus 9, and then 2.4 into 10 power minus 9, like 8.1 into 10 power 7, right? Minus 7, okay. And also you can see that the error for recursion plot is about 9.9 into 10 power minus 1, okay. So when seeing that error, right, so error is very minimum, right? So I think that trained neural network provide exact output of that collected data, right? Input and target data. So if you want to test this condition effectively, then you have to click this plot regression plot, right? Plot regression, right? So here you can see that means how that target and input is. Once again, yeah, here. So how the target and trained neural network have the difference, right? So when you have to have that R value equal to 1, so no problem. That means what's the meaning when R equal to 1? That means the trained neural network output is superimposed with that target output, right? So here you can see that. So the blue color is fitted, that means trained data. So the circle one, right? Black circle one is the data we collected. So you can see that the both data will be superimposed to each other. That means the output of neural network is have exactly as our target, right? So that's why you are getting R equal to 1. So when is R is nearer to the 1, that means 1 or 0.99, right? So you don't worry about that. That means, and also you will see that this plot, right? You will get some idea, right? So if suppose the target and your trained data is superimposed to each other, means the trained neural network have a better result with your target, right? So you don't want to retrain this model, right? Straight away you can use this model for your application. Next process after seeing this details, right? Mean square error and then a regression plot, right? So next you have to go to here they ask about once again you want to train again or not, right? When that mean square error and R value is equal to 1, that means no problems. So you have to go for next step. Okay, next step, how we are going to use this neural network, right? So here I'm going to use that neural network in the Simulink diagram, right? So that's why I'm going to generate Simulink diagram this of the trained neural network. So for that I'm going to click this one. So after clicking that Simulink diagram, you will get this model, right? So this is a trained neural network for the given input and target. So now I'm going to test this model, neural network model with the change in degree, right? So input will be theta, the output will be should be sinusoidal, right? So for that I'm going to take a repeating sequence, right? In repeating sequence, I'm going to fix the frequency. Here only you are going to fix the frequency for the sinusoidal. So here you can fix the frequency equal to 1 Hz, right? So and then the output will be should be vary in between 0 to 360 degree. So initial ramp will be 0, the final value will be 360. Okay. So I'm going to vary the ramp in between 0 to 360, right? And then I'm going to check the result of the neural network after simulation. So here what will be happen, you are not getting sinusoidal because this is because of that sampling time of this Sumling block, right? So this Sumling diagram have some sampling time, okay? So that should be adjust accordingly. So here in the maximum step size, right? So it will take auto. So here you can change that sampling time to, that means maximum step size to e power minus 5, right? So this is going to be considered as a sampling time here. So next you have to simulate the same model. So now we'll see that the output from the neural network, right, is a sinusoidal, right? So we did that neural network model for generating sinusoidal based upon this data, right? So by the way, you can train the neural network for the particular application, okay? So then we have to discuss how we can use ANFIS, training of ANFIS in the Matlab. So you have to consider same data, theta and the target. So here you need to, for example, when you have to train the ANFIS network in the Matlab, so it should be in matrix form, right? So in neural network, the data input and the target will be in separate matrix, right? But in case of ANFIS training, so it should be in the same matrix. So you have to use another time data equal to theta. So first column first should be input and second should be target, right? And then you have to take transpose, right? Be column matrix, transpose of the matrix. So next you have to simulate this, execute this file. So now we will get error, what error we are getting. Transpose. So otherwise you use this. Yeah, so you have to take transpose, right? So now you can see that here is the final data. The first column is known as input data. The final one is normally is ANFIS training in the Matlab, right? The last column always considered as a output or target, right? So the last one is going to be considered target. The first one, for example, you have uh, 4 column, right? 4 column. The fourth one going to be considered as a target. The remaining 3 will be considered as input for that ANFIS training, right? So here there are only 2 data. One is input data, another one is target data, okay? So it's going to be considered as a training sample for that ANFIS training, okay? So in order to execute that ANFIS training process in Matlab, just you have to type ANFIS edit, okay? ANFIS edit. So after typing ANFIS edit, right? So you will get this window, right? Neuropathy designer window, right? So in this window you are going to do a training process. So it have different section, right? And then that output target displaying section, this one. So you are feeding some data, right? The final target detail will be appear here, okay, in this here. So this is known as data loading part, right? So input and target data going to be loaded in this section, right? So after that you have to generate some initial memory function for that neuropathy and this, right? So initially, okay, so that happened in this section, right? After generating initial memory function, we go for training process. So you have to use this option, training fish, right? So here you have to do the training process. So then we have to take testing of that trained fuzzy inference system or a trained ANFIS. Okay, here. And then you can see the structure of that trained ANFIS, okay, adaptive neurofuzzy inference system from here, right? When clicking that structure, you will get that structure of that ANFIS trained network, right? And then you can finally, after training process, you can save the data. You can save that fuzzy inference system by using that file, right? So this is a different option in that neurofuzzy designer. So here you can click this. That means data is available in the workspace only, right? So you can click this one and then click load data, and then feed the data here, data, and then click OK. Okay. So here you can see that this is the target data you are collected. Okay. So after loading this data, next you got to generate the initial membership function, initial fuzzy inference system. You can use a grid partition method or a subtractive clustering method. So here I'm going to use grid partition method. So just you to click this generate fish. So there are only one input, right? So that's why here you have only that mean number of membership function for only one input, and then you can see, choose the different membership function from here. You can choose triangle, trapezoidal, bell-shaped, Gaussian membership function. So whatever maybe you can select from that option, right? So I'm going to select triangular membership function here, and then here you can see the output membership function type, whether you want to use constant or linear, right? So linear means I told earlier, right? That means it have some equation f equal to p plus x plus qy plus r, right? So here that linear function, right? The p q r will be tunable parameter. When you use the linear function, that use that linear equation, otherwise it has only constant value. So constant means it like a weight value, right? It won't be updated accordingly, right? So I'm going to choose constant here and click OK. So that means initial membership function will be created. Next to process, we have to use training, that means optimization method. So here there are two training method. One is hybrid and back propagation. So hybrid means you have to combine both back propagation plus a least square method algorithm. So back propagation going to be adjust the membership function of that means input membership function parameter, and least square method going to be tune the parameter of the despecification layer, right? So this is a concept. So I'm going to use hybrid membership function here, and then I'm going to take number of iteration 1000 as like a neural network, right? So I'm going to train the model. I'm going to train the model here. So you will get variation in the training process here, and also you will get the training error. So next you can, after training process, next you get to test the model. So here you can see that that means trained ANFIS is not matched with your target, right? Then once again you go to train the process. So you can train the process up to you are getting the minimum root mean square error, right? So this portion only aligned correctly, right? The remaining portion is not aligned correctly because of that root mean square error, right? So then you can increase the number of iteration, and then you can wait for that iteration completion process, right? So this is because of your theta value, right? That means theta and then theta value have the range in between 0 to 360, right? So not acceptable by the data increase network. If suppose I'm going to change the data, like the data in between, for example, I'm going to take sine of theta and then I'm going to consider here that 2 pi, right, radian. Here I'm going to consider 2 pi and then I'm going to generate the data here. Okay, so and then this is going to be taken as a training data for this network. So I'm going to clear everything, clear plot, clear data, and then now I'm going to load the data. And then once again I'm going to take same process, same thing, right? I'm going to consider 1000 iteration and next I'm going to train the process. So now you can see that because of change in data, right, the reduction in that input data value, right? So the training process in the ANFIS will be have some good response in the training, because the fuzzy inference system normally designed in between some ranges, right? Above that range, the ANFIS not give proper output, right? So here you can see that, yeah. So now we can see that, the training error is around 0.135, no problem. I'm going to test the model. So now we can see that the trained, the red color is the trained neuropathy inference system. The blue color nothing but your that means given target data. So both are superimposed each other, right? So now that ANFIS is trained with your target data, and then you can see the structure of that ANFIS. So this is single input, single output ANFIS network. So this is a layer of that different layer of that ANFIS network, right? So next process, you have to save this file as like that main fuzzy inference system. So just to go to export and go to file, right? So I'm going to save this file as test. Okay. So, and here you will get that fuzzy inference system. So next we need to test the fuzzy logic, right? So here you can type fuzzy and then input for that fuzzy, that means file name is should be equal to test, right? Yes. And then you can use the variation of triangular in between two. Okay. And then I'm going to combine this output of neural network with the fuzzy logic, right? I'm going to combine both. So next you have to check the result. So the yellow color is output of neural network, and the blue color is output of adaptive neuropathy inference system, right? When comparing these two, the neural network provide the better result than the adaptive neuropathy inference system. But we need to make, we can make the ANFIS adaptive neuropathy inference system very effectively according with the selection of input and output data, right? You can normalize that input output data accordingly, and then you will get the result. So this is a simple program used for train the neural network and fish in the Matlab. So next you have to move on to how we can implement the same concept for applying MBPT, right? So first I'm going to explain about basic things about that mean T. That means we need to select solar panel, right? Solar panel. So solar panel normally receive two inputs, right? So one is temperature, another one is irradiation. Okay. For example, consider this is irradiation and this is temperature. Okay. And then you have some load, right? This is load. So when you have to apply MPPT algorithm in between the solar panel and the load, right? You have to use converters, right? That means DC to DC converters. Okay. So the panel is connected to the DC to DC converter, and then the converter output will be connected with the load. After that, you have to implement MPPT to extract the maximum power from the panel. So here we need to use MPPT algorithm, right? So MPPT. So normally MPPT receive different kind of inputs. So can we use voltage and current of that PV panel, right? That means PV voltage and current, VPV or IPV. So and also we can use uh, environmental condition like irradiation and temperature. So you can use different parameter for as input for that MPPT algorithm. So we can use voltage and current, and we can use irradiation temperature. Here we are going to use that artificial intelligence technique, that means AN and ANFIS, right? So then we need to choose only two parameters. So one is irradiation and temperature, because we are going to make one model. Okay, that model known as solar PV model based upon ANN and ANFIS. So it's going to mimic the process of or working of that actual solar panel. Okay. So we are going to model that solar PV by means of ANN and ANFIS. So this ANN and ANFIS is going to be receive two inputs. One is irradiation and then another one is temperature. So the output maybe we can consider different outputs. So that means current at MPPT point, right? Current at MPPT or voltage at MPPT or power at MPPT. Okay. So here I'm going to consider only one output. So one is you have to collect voltage at the maximum power point. That means voltage at maximum power point condition for the different irradiation and temperature. Okay. So you have to make that model, exact model of the solar PV panel by means of ANN and ANFIS. So input will be going to be taken as irradiation and temperature. So output going to be taken as voltage at maximum power point. So next process we get to compare this output from that ANN and ANFIS with the actual output of PV panel, right? So you have to take PV panel voltage here, VPV. So this is nothing but a VM. So you have to compare both. So after comparing, right? After comparing, it going to be processed via some controller, PA controller. So this PA controller then is going to be processed via PWM generator, right? PWM generator. So then the PWM generator will provide pulse for that switches used in the DC-DC converter, right? So this is a process of maximum power point tracking algorithm implementation in the solar PV model. So when we have to design this model, right? So first we need to fix the panel rating, right? So what's the maximum rating, power rating of the panel, and then voltage rating, and then current rating, and also you have to fix the load, power rating, and voltage rating requirement. That means power rating. Power rating normally is same as the solar PV, because so here in MPPT we are going to match the source resistance with the load resistance. So then only we can transfer the maximum power from the source to load, right? That means maximum power point. That means maximum transfer power theorem, right? Maximum power transfer theorem. You know that circuit theory, right? On theorem in the circuit theory. So by using that concept, the logic, you are going to make the source resistance equal to load resistance by adjusting the duty cycle of the DC-DC converter. So this is a concept of that MPPT algorithm here, right? So here we need to fix the voltage, output voltage requirement, and load current requirement. So first you have to fix the power rating of the panel, and then you have to fix the rating of that load, and then you have to fix the rating of that DC converter. That means you have to fix the parameter of converter, right? That means like you have to find out the value of L and C for the particular configuration, right? So this is a process of designing that solar PV panel, solar PV system, right? So here I'm going to take 250 watts panel, right? 250 watts panel with the voltage rating of that means standard test condition 30.7, and then current about 8.11 or 16. Okay, so I'm going to take the panel rating here 250 watts, 30.7, 8.16, and then output I'm going to fix equal to 60 volt, right? 60 volt. If I'm going to fix 60 volt, and the current will be at the load side, the maximum current will be equal to 250 divided by 60, right? So this is a maximum current when I'm going to consider the voltage is 60, right? The maximum current for that load will be 250 divided by 60. So as per maximum power point tracking algorithm, we are going to match the resistance in both sides, right? Source and impedance. Then I'm going to consider the same power will be passes through that load, right? I'm going to consider there is no losses in the system. So 250 divided by 60. Okay. Based upon this input voltage current and output voltage current, you have to design the value of L and C, right? So this is a process of designing that solar PV system. Next, you have to see that one in the Matlab. So I'm going to take solar PV panel, right? Otherwise, just to click this one, go to Simscape, go to power system, and specialized technology, go to solar, right? So PV array, you have to take this one. So here I'm going to fix that rating, right? 250 watts panel. Here I'm going to choose this one. Yeah. So I'm going to use the 250 watts panel, and then I'm going to fix the parallel string equal to 1 and the series string equal to 1. Okay. And then here you can see the different plot, right? IV PV plot of the particular PV array, right? For different irradiation condition. So here you can see that. So this is a maximum point for the 1000 watts per meter square. This is around 249 watts. For 500 watts per meter square is around 126.3. For 100 watts per meter square is 24.25. Okay, so this is a power, peak power for the different irradiation condition, right? So you have to take this one. So next you have to use, I'm going to use boost converter, right? Because input will be 30.7, output will be 60 volt, right? So you have to use boost converter. So in between you have to connect inductor, capacitor and power switches, right? So I'm going to take series RLC branch. So inputs I'm going to place some capacitor. Next I'm going to connect inductor. And then we have to use IGBT or MOSFET. Choose IGBT. Here I'm going to take IGBT. We take IGBT here. After that we need diode, right? Diode. So you have to connect diode here. And then we have finally capacitor here. And then we need to connect load. Here we need to connect the load. So in the load side you have to measure current, right? So you type current measurement. So you have to connect this here, right? Output current measurement. And also you have to measure the output voltage, right? So just you have to type voltage measurement. Okay, so you have to find out the value of this L and C first, right? So based upon this fixed voltage, and that means panel rating and the outload rating, right? So it will receive two inputs, right? One is irradiation, another one is temperature, right? So I'm going to use this one, irradiation. So this is for temperature. So I'm going to fix irradiation equal to 1000 and then temperature equal to 25. So in order to generate pulse, we need a neural network, right? And we need to design this process. So wait, I will open that detail. So first you have to design the boost converter, right? So you take the input voltage of the boost converter. So this is a design equation for that boost converter. Okay. So you have to take the input voltage is 30.7, and I'm going to fix the switching frequency equal to 10 kilohertz. The output voltage equal to 60 volt, and then the output maximum current will be 250 divided by 60, and then I'm going to consider inductor ripple current and ripple voltage percentage here, right? And then I'm going to execute this. So this is a calculation of the inductor capacitor here. I'm going to use the capacitor only in both side, input and output side. Same value I'm going to use. And and then here R is 14.4. The designing process over. So next you have to design that neural network, right? That means we have to use the same data. Okay, same data in this model, right? So here we have to create some PV panel equation, right? So just you have to use the same data of that PV panel model here, right? Short circuit current, current at maximum power point, open circuit voltage, and then voltage at maximum power point, alpha, current temperature coefficient, beta, voltage temperature coefficient, and then a standard irradiation temperature, right? And then you have to collect the data for I equal to 1:1000. So I'm going to collect 1000 data here. Okay. So in order to make that exact model of the solar panel by using neural network, right? So it should be received two inputs. One is temperature, right? So one is temperature, another one is irradiation, right? So that random temperature irradiation is generated based upon these two equation, right? And then I'm going to collect the output is VMP, right? Voltage at maximum power point. So by using this formula, you have to generate the maximum voltage of the for given irradiation temperature, right? So finally, you will get the input here, right? So this is input and this is output after executing that program, right? This is input data, this is output data, right? So I'm going to execute this program. So after executing, we'll get input data here, right? This is input data and then this is output data. So this is going to be used for train the neural network. So once I go to and then start and then use same fitting app. First you have to cancel, finish this one, click this one and then click next button, and first you select the input data, right? Here is that input data. Yeah, this is input data, and then you have to select the output data or target data. So this is target, and then click this matrix row, right? So now click next button, and then here already as discussed, right? The number of samples given for training, testing and everything, right? And click next. Here you got to fix the number of neuron. I'm going to take same neurons and then click and train now, right? So after training process, you will get mean square error and regression error right here. Next you have to click plot regression. So now you can see that the value of R equal to 1, so no problem. That means the target data is superimposed with the trending data. So we go for next process. I'm going to use that Sumling diagram, right? That means in the trained neural network. So this network going to be used for implementing MBPT in the PV panel, right? Solar PV system. So it received two inputs, right? I'm going to use max. So one is temperature, another one is irradiation, another one is temperature. So here I'm going to use go to block. So this is irradiation, or I'm going to mention G, and then another go to block. So here I'm going to mention this is equal to T, right? I'm going to use these two. So this is the input of the for that neural network. So next process, so the output will be voltage at maximum power point for different irradiation temperature. So it should be compared with the PV voltage. So I'm going to do some another measurement. Go to and connect this data. So this is PV measurement, and then I'm going to take this one, and then I'm going to use bus selector. So I'm going to select only voltage from that PV panel, or I'm going to select voltage current from that PV panel. So this voltage and then current, you have to remove these two signal. So first one is voltage, second one is current, right? So next I'm going to compare this both actual voltage of PV panel with the neural network output. So for that I'm going to use summer. So here I'm going to use rectangular plus minus. Okay, and then connect here. So next I'm going to, after comparison, there will be error. The error should be minimized by means of some controllers. I'm going to use PID controller, right? PA or PID. So same data, I'm not changing anything here. I'm going to use same value, right? Next I'm going to use PWM generator. So generated here, sorry. So the frequency is here 10 power 3, right? 10 kilohertz. So that's going to be given to this IGBT choose, and then we have to measure the power of the PV panel. So for that I'm going to use product, this one, and then we can see the results by using scope. So we can so power of that PV panel, and then power of output load side, right? And then you can see the voltage of PV panel and voltage of load, right? So these things is implemented here, right? So next you have to simulate this model. So first you have to save this model, test 1. So here we need to add another block, nothing but power, that means where is that? Power, yeah, this one. So here I'm going to simulate this model. So here you can see that for 1000 watts per meter square and 25 degrees Celsius, the maximum power is 250 watts, right? I'm going to maximize this one, right? And then output load power is around 250. It has some losses. So this is in PV panel voltage is around 30.7. Okay. So this is load voltage is around 60 volt, what we have designed, right? So next I'm going to change the irradiation, right? Irradiation to 500, right? So next you have to check the response. Yeah. Now see that power is for 500 is around 125 watts, right? So this is load power. So this is PV, voltage and this load voltage, right? So for changing irradiation also you will see that you will get that mean that implemented MPPT algorithm extract the maximum power from the PV panel. Okay. So this implementation of neural network MPPT, that means artificial neural network MPPT for a solar PV system. Okay. So next you have to implement the same concept for that ANFIS, right? I'm going to save this one. So in order to implement that ANFIS, okay, you have to take same detail, but we need to change the data, right? So data, we need to generate data equal to one is input, right? Input, another one is output, right? Next I'm going to execute same program. What's the problem? Yeah. So this is the final data we are getting for ANFIS. So here you can see that. So data, the first two inputs, that means irradiation temperature, the output nothing but voltage at maximum power point. So this is going to be taken as training data for that ANFIS. So I'm going to type ANFIS edit, and then first I'm going to load the data. So here I'm going to load the data here. So this is collected data for different irradiation temperature. I'm going to generate initial fish. That means I'm going to consider 3 membership function for irradiation and 3 membership function for temperature. And then the type of membership function is triangular. As for output, I'm going to consider once again constant, right? And then I'm going to train the model. So I'm going to consider 100 iteration. I'm going to train the network. Yeah, now you can see that the error of this system is around 3.754 into 10 power minus 7. So the error is very minimum. It's nearer to 0, right? So next I'm going to test the model, test the trained network. So here you can see that the red color is trained output and blue color is target output. So both are superimposed each other, so no problem. So we are getting, that mean the output of trained network and fish network is have same output of the target. So we can use the same model for implementing the ANFIS MPPT. So next we can see the structure. Yeah, it have two inputs. It receive two inputs. Okay, and then one output. In between we have input members function layer, rule layer, and then output members function layer, right? Next you have to save this data first. So that means in form of a scene from system, and then go to export and click to file and save the data. So I'm going to save the data as test1. Already is there test, right? Test1.fas. So this is a trained for scene from system. So next I'm going to I'm going to save us this file. Save us to test2. So instead of neural network, here we are going to use that fuzzy inference system. So I'm going to delete this one. I'm going to use logic control. So that's going to be connected here, and then you have to provide inference system detail here. Okay. So next I'm going to simulate the same model. So here initially I'm going to fix irradiation equal to 1000, and then I'm going to simulate this model. So now we can see that. So after implementing and fees, so here also we will get the max.
In the forms, if we created one form, how to make it duplicate?
Ma'am, you go to the share option, ma'am.
Wait 1 second, let me open it.
Okay.
Ma'am, kindly.
Share option.
Ma'am.
Share as template இருக்கும் பாருங்க ma'am. Get a link to duplicate.
Get a link to duplicate இருக்கே.
அதை click பண்ணுங்க ma'am. You'll get an URL. அதை
Hello.
copy பண்ணிடுங்க.
Okay.
இப்போ அது வந்து you paste it in a new tab.
Tab and tab, form tab la.
Browser tab. Chromeல ஒரு tab open பண்ணி place.
Shall I proceed? Hello.
Yes, sir.
Yeah. So for after implementing that ANFIS MBPT, right? So here you can see that the maximum power extraction is around 250 watts, right? For 1000 watts per meter square. So this is the power of that converter output load power. So this is PV panel voltage, and then this is load voltage. Okay. So next I'm going to change the irradiation here also. So here also you can see that the power is extracted at maximum level is around 125 watts, right? So this is the power of that load, and then PV voltage and load voltages. Okay. So this is a simple thing that mean implementing artificial intelligence, that mean like ANN and ANFIS for a solar PV system. So that's all my presentation. Do you have any questions? So kindly, if anyone having question, kindly ask me. So can you give me 2 minutes break?
Can I come?
So can you give me 2 minutes break, right? I will come after 2 minutes, right?
Okay.
So
I thought can I ask the question, or shall I wait for your return?
Sir, wait for 2 minutes, sir. I will come.
Okay.
Okay.
Can I speak to the organizers or Mr. Mariappan, please, for a minute?
Sir, tell me, sir.
There was one lady who asked some very interesting questions. That means when we do this Matlab presentation, I have to be on another computer operating that Matlab, is it? That's the way I can learn, is it?
Yes, sir. Yes, sir.
Oh, this is really fantastic.
You
okay,
sir,
I just
you
want
should have the software. You should have downloaded the Matlab software also.
Okay. And that is offline, or it has to be on the net?
So I have not heard that information. It will be online only. Even if it is online or offline, you have to be logged into a Matlab. You have to logged into your laptop. Then only you can do it parallelly.
No, that is all right. I can log into a Matlab, but has that does that operation require to be online?
I don't know. They have told me it is online only. Now it is online only. There is no possibility for offline.
Okay.
Sir, we can download the Matlab software 2021 offline, and we can do the simulation.
That means I go to the system and download the Matlab.
Yes, sir.
And I can operate it offline. There is some internet problem at my side. Supposing I want to learn this Matlab business, I download it on my laptop and try and experiment. Madam, thank you very much for clarifying. Right. Okay.
But actually, sir, your sister will be very much interested to guide you, Dr. Kalyani ma'am. but she is very busy now.
Yeah, in this world, everybody is busy. Who can teach? Who can teach me? I am so. I'm not. I'm not a young fellow of 25 years where I can run and learn. All right, nice. But at least I know something is available in the world.
Yes,
For the first time, I'm sharing this with this group. It doesn't matter. It is for the first time I'm understanding that a Matlab is there, and in that Matlab you fix all these things, and you can do that. Artificial neural networking on this ANFIS or whatever. But I want to speak to the presentation to Dr. Premkumar when he comes back on some technical issues. Let him come back.
Sir, sir? May I tell something, sir? The interest what you have towards MATLAB will make you learn it very quickly, sir. You have so much of interest, sir. So age is not a bound. You can catch it up easily.
Okay, madam. No, this is the way in 2000, when I was going through a training in administrative staff college, they taught us this Excel and all those operating systems, etc. The presentation looked very easy. When it came to operation, it looked a lot of exercise, and it requires continuous study and continuous. I believe that you have to learn these things only by making mistakes.
Yes, sir.
Okay.
Few mistakes.
Thank you, madam.
Hello.
May I know who is this lady speaking? My name is P.R. Iyer, madam.
My name is Dr. Teresa, sir. I am from
nice.
New Prince.
You are from?
New Prince Engineering, Shri Bhavani College, sir. I am working with MATLAB, so I know it is very good. And if you show some interest, you can catch up easily. That's why, sir. Sir is back. You can ask him.
Okay. Dr. Premkumar.
Yes, tell me, sir.
Very nice presentation you have made both for ANN and ANFIS, but most of your presentation look to be the operation of MATLAB. Finally, it comes to the efficient or knowledge in the operation of MATLAB, on which people like me are still to get in. But one doubt came to me. Now you put that circuitry for the optimum discharge of power from the solar panel to the load. That circuitry consisted of capacitance and inductance and probably some resistance also. I couldn't see the resistance. Anyway, capacitance and inductance were there. Now, how do you figure the values in farads and Henrys for these items, or is it designed in the MATLAB itself? How does it work?
No, sir. That means so based upon your power rating requirement from your input side and load side, right? So your input voltage will be 30.7, right? And then load side, my requirement is 60 volt, right? Then we must use some boost converter, correct? So, so for boost converter, we have standard equation for designing that LNC. So that's why already I present you. So I will present once again. That mean these equations. You can see that, sir?
Yeah, I can see. Unfortunately, I am on my mobile, so the pictures are very small. Okay.
So this is standard equation for designing the LNC for boost converter. So based upon our power rating and input voltage, output voltage, and output load current rating, right? So here we have to design by using these formulas for the LNC. Clear, sir?
Okay. The design means I don't get the figures, na? Do I get the values in farads and Henrys?
Yes. Here you can see that, sir. Once again, after executing this one, right, you will get this value, right? Here, value for L and value for C. You got, sir?
I got it. I saw that after executing, you have got some L is equal to 0.104. It is what, millihenries or henries? How much? What is it?
Henry.
Or is it ohms? Is it ohms?
Yes, yes. R is ohms. C in farad.
No, R is ohms, but L is how much?
Henry.
And capacitance is in some picofarads or farads?
Farad.
Okay, thank you. I have understood that if one does not learn MATLAB, this knowledge of input output is only so very superficial. So thank you. This is the lesson I got from this program.
Okay. Thank you, sir.
Thank you.
Any questions from audience? Any questions? Any feedback?
Sir, for machine learning, how can you implement, sir, for machine learning? So this is supervised learning, correct, sir?
Yes.
For unsupervised learning, learning from experience, how can we convert the same thing?
And means you have to use that unsupervised model like fuzzy Seaman clustering and then CNN model, right? So like that AI and ANFIS, right? You have to develop that model for implementing that MBPT. Just go to Google it, ma'am. Google it some detail relevant to your topic. So definitely you will get some idea in the internet, right? But you need to take the proper link for understanding that. You can type type relevant to your topic, and then you will get some better results from the internet. Try to study from internet regularly. One day you will get some answer about your particular projects, right? Any other questions? Rajesh Babu, sir?
Sir, sorry, he is in another meeting also, sir.
Okay.
So if you concluded, we will send the feedback after some 5 minutes, okay? So we are in the another meeting, sir. Anything has to be informed to Rajesh Babu, sir?
No, sir. Yes, I asked Rajesh Babu whether I close this meeting or that.
Okay, sir. Participants, any questions? If there is no questions, we can conclude. Okay, sir. Thank you very much, sir. Thank you for your time, sir.
Thank you, sir. Thank you.
Thank you. Participants, the feedback link will be shared in a few minutes. Okay. Otherwise, you can fill it up during the afternoon session, starting of the afternoon session. Thank you. Thank you so much.
Thank you all. Bye-bye.